Have you ever wondered how a bolt of lightning, a phenomenon of pure raw power, could be generated in a laboratory setting? Today, we shed light on a device that has been mimicking this natural spectacle for almost a century, the Van de Graff Generator. Invented in the early 20th century by an American physicist, Robert J. Van de Graaff, this generator is a popular spectacle in science exhibitions and physics classrooms. But what makes it so fascinating? Let's delve into the heart of this machine and unravel its secrets. The Van de Graff generator is a simple device with a complex function. Its primary components include a large sphere, a rubber belt, a lower roller, an upper roller, and a brush. The machine starts its operation with the lower roller, which is usually made of silicone rubber. This roller begins to turn, driving the rubber belt that connects it to the upper roller. As the belt moves, it carries with it electrons from the lower roller, leaving the roller positively charged. The belt, now negatively charged, continues its journey upwards towards the upper roller, typically made of metal. Here, the electrons are stripped away, leaving the belt once again neutral. The metal roller, now brimming with extra electrons, becomes negatively charged. A brush, connected to the large sphere, sits near the upper roller. This brush collects the electrons from the roller and transfers them to the sphere. As more and more electrons accumulate on the sphere, it becomes negatively charged. But why does the sphere not simply discharge all these extra electrons back into the air? This is where the ingenuity of the Van de Graff generator comes into play. The sphere is insulated from its surroundings, preventing the electrons from escaping. This causes the sphere to build up a large negative charge, sometimes reaching up to several million volts. It's important to remember the fundamental principle of electricity. Opposite charges attract, but like charges repel. So, with such a large negative charge, the sphere repels any nearby negatively charged electrons. This leaves the surrounding air positively charged. When the charge on the sphere becomes too great, it discharges in the form of a spark to the positively charged air, mimicking a miniature lightning bolt. In summary, the Van de Graff generator works by using a rubber belt to transfer electrons from a lower roller to an upper roller. A brush then collects these electrons and transfers them to a large sphere. This sphere accumulates a large negative charge, which eventually discharges in the form of a spark. The Van de Graff generator is a testament to the power of science and the human spirit of curiosity. It takes a natural phenomenon, lightning, and recreates it in a controlled environment. By understanding and harnessing the principles of static electricity, we can bring the power of a thunderstorm into the palm of our hands. And that is the magic of the Van de Graff generator.